the Great British Manufacturing Podcast, brought to you by MTD, MFG and Jefferson.
Hello and welcome to the Great British Manufacturing Podcast. On this week's podcast, we will discuss the latest positive news from the British manufacturing sector and welcome a special guest, Rich Proctor, AME3D's Managing Director. My name is Joe Reynolds and joining me is Stuart Whitehead. Stuart, welcome.
Morning, Joe. Good to get the old team back together.
Yeah, quite, absolutely. And we're going to start with a cracking story. There's big news coming out of Norton to start the podcast, isn't there?
Yeah, so this is breaking news. The historic motorcycle manufacturer has officially opened its new factory at Solihull Park in Solihull. The firm, which was founded in the 1890s in Birmingham, was based in Castle Donington until it entered administration at the beginning of last year. In April 2020, TVS Motor acquired the iconic brand, famous for models such as the Atlas Commando, Dominator and Navigator, many more, for £16 million. Norton also has a rich history in motorsport and brand name is synonymous with the Isle of Man TT. In addition to production, the new headquarters will be home to design, engineering, purchasing, sales, marketing and support teams. Information still coming through, but we believe it has a capacity of around about 8,000 bikes per year. So great news for the Midlands. Wow. And great to see Norton back.
Yeah, and I have to say, we talk about a lot of new factories, don't we? And they're quite often are attractive. And this Norton's no different. It's a stunning place.
It really is. Seen some of the images, and hopefully people will look at the images very soon on MTD, MFG and Jefferson. Fascinating place. And yeah, can't wait to go down there and hopefully do some filming with the guys at MTD, Joe.
Yeah, sure. This next one, I'm pleased to say, got a little bit of coverage in the mainstream media, nowhere near what it deserved. But small nuclear reactors are set to be built in the UK. This is great news. Clean energy, thousands and thousands of jobs. What is there not to love?
Absolutely. So Rolls-Royce has secured more than £400 million of funding to develop small nuclear reactors, which could create 40,000 jobs by 2050. The creation of the Rolls-Royce small modular reactor business was announced following a £195 million cash injection from private firms and a £210 million grant from the government. The investment by Rolls-Royce, B&F Resources, Exelon Generation and the government will go towards developing Rolls-Royce's SMR design. And interestingly, for the manufacturing sector, identifying factories which will actually manufacture the reactor's parts. The vast majority, 80% plus, will be made in the UK.
Yeah, great news all around. This is an announcement I didn't see coming, to be honest with you, but very welcome indeed. Yorkshire-based ITM Power, they're expanding.
Yeah, again, we've covered hydrogen a couple of times. ITM Power, the energy storage clean fuel company founded in 2001, has reached an agreement to acquire a site from the University of Sheffield at a cost of just over £13 million. And this is part of a wider £250 million expansion programme for the hydrogen specialist. ITM intends to build a 260,000 square foot factory at the site, which is just a couple of miles from its existing facility in Sheffield. Expected to be operational by the end of 2023. The world's largest electrolyser production facility is expected to create 300 jobs.
And Almac, they're creating 1,000 jobs, this time in Northern Ireland.
Yeah, Almac set to create 1,800 jobs across its global operations over the next 3 years. And as you say, 1,000 of these will be in Northern Ireland. New jobs will include operational, supervisory, managerial roles, including graduate opportunities. Over the past 18 months, the contract pharmaceutical development and manufacturing firm has been instrumental in providing support to over 140 separate research projects for COVID-19 vaccines and treatments through a range of services. So good to see them benefiting from all the work that they put into developing a vaccine.
Stuart will take a brief pause from this week's UK manufacturing news and introduce this week's special guest. He's no other than Rich Proctor, Managing Director of AME3D. Rich, a warm welcome to the podcast. Thanks for joining us.
Yeah, thank you for having me on. Yeah, it's good to be here.
Just to start with, we like to talk about you, not just the company. So tell us a little bit about yourself, your current role and some of your responsibilities.
No problem at all. So I'm working for AME 3D, but I did a mechanical engineering degree. Not necessarily the most exciting, but probably something that a lot of your listeners have done. And from that, I went to become engineering intern at a magnetics company, Arnold Magnetics, and kind of worked my way through the ranks with Arnold. We did all sorts of interesting projects. So I was started out as a student intern, doing all the kind of rubbishy jobs, the first line of defense for any problem on the shop floor, whatever it was. Then joined the engineering team full time, became a senior engineer, got a little team of a couple of engineers working alongside me, looking after the prototyping that we did. Then I took on the prototyping department with some shop floor staff as well, and some other engineers. So it was a kind of enjoyable career in magnetics, interesting place to work. You can't, when you're working in magnetics, you can't ever put a tool down without thinking, because it'll move itself towards whatever you're assembling or machining. So yeah, it is a nightmare, but it is a really interesting place to work. So really high precision machining, really broad set of sectors to work in. So in the same day, you could work on things like heart motors, ideally for keeping people alive, stuff in motorsport, Formula One, oil and gas. We did a lot of work in electric aviation, and then I kind of moved on with the sales team, looking at how we can start developing production lines to put in other people's facilities. It was a really interesting place to work. And then I moved from there, having spent a lot of time in the prototyping, moved to AME Group, and that's a product development consultancy. My experience of prototyping, taking people from that position of kind of concept through to production, was one of the reasons I've kind of been a reasonable fit at AME Group, even if I do say so myself. AME Group's kind of 25 years old as a product development consultancy. Started out after the owner was made redundant from the coal board, and now our facility is actually on an old colliery site. And this last year, we landed some Northern Powerhouse funding. We got £750,000, and one of the things we've done with that is kind of launch the AME 3D brand that I'm leading on, and that's because we were doing some kind of additive work as AME Group, but it wasn't that clear. Some of our customers didn't really know about it. We also have a design team, so we wanted to make sure people knew that we were really all about additive production. So that's what we've done.
It sounds really interesting. It's when we look at the AME Group, just can we dive a bit deeper? Tell us a bit more about the group and also a focus on AME 3D.
Yeah, so AME Group as a kind of whole is a product development consultancy. We try to help people get from concept to production is the target. So there's a design side of that, and then the production side of that. AME 3D it kind of started out as a prototyping facility, helping all sorts of different companies get their prototypes in the very early days of 3D printing. So a lot of our machines initially, 20 years old, from when people couldn't afford to bring these in, they'd come to us and we'd produce their prototypes for them. And we've got a reasonable set of kit now in our facility, and we help people both on the prototyping, so getting a kind of first model made so they can see what it looks like, do the parts fit together how they expect, do the split lines on casts work well, do they kind of feel just about right in the hand, all those sort of things. And we've got kit here that'll allow us to do really fine detail, so the kind of detail that you'll see on a kind of a model locomotive. We can do the rivets and stuff down to 50, 60 microns in diameter, stuff like that. So we've got the fine detail. We've also then got actual end use engineering plastics that we use for kind of stuff that people can grab and throw about, and they hopefully don't break for them. We do things, and we also, alongside the kind of additive work, we do casting as well, plastic casting, so vacuum casting, rim casting, and a lot of that is for end use parts, which it's another kind of additive process, but slightly different to the layering process of 3D printing.
No, fascinating to hear about your background and the company. And taking it back a stage, I'm sure most of our audience will be familiar with additive manufacturing, 3D printing. But for those people less familiar, what exactly is it, Rich?
So generally, additive manufacturing, 3D printing, they work on the same kind of basis, where you take a 3D model of an object, you slice it up layer by layer. So depending on how accurate you want that to be, that can be kind of 0.1 of a mil layers, 0.5 of a mil layers, something like that. And then the material is layered up, and for our processes, we use laser curing or laser sintering of those materials. So we would have the laser draw the shape of that single layer in the material, and then we put another layer of material on top. The laser would then cure or sinter the next layer of material, and gradually you build up a 3D shape layer by layer. And the finer the layer, the better the final part looks aesthetically. The thicker the layer, the kind of coarser it is. The reason I say generally additive works on that kind of process is also kind of casting is an additive process that we do, where you'll take a part that has been for us produced on our SLA machines. We then finish that back so it looks like the end part. We wrap it in silicon. We then take the silicon apart, put it back together without the original part in, and fill that cavity with polyurethane, and that sets, and then you have a kind of a usable end use part. Some of the SLA materials are quite brittle, but when we use polyurethane, it's really, really kind of tough, ready to use for end use parts. And we can simulate stuff like rubber as well, so people can use those for actual what they want them for in the first place, without having to go to hard tooling.
No, perfect. Thanks for explaining that. And so, in terms of the features and benefits and the advantages of additive manufacturing and 3D printing, what would they be?
So I think there's a number of things that are really beneficial in additive and printing. You've got the opportunity to basically create whatever shape you want. So previously, when I was working at Arnold and we were machining things, you can't machine a complex geometric tube through a block of material. That's just not an option. You'd have to make it in several parts and put it together. Whereas with additive, you can do that. You can make really complicated parts. So we've done stuff for kind of wind tunnel testing or fluid dynamic testing, where we've produced something in a clear part with complicated tubes through the part, so people can pass fluid or gas through that, and they can see what's going on, and they're not having to machine really, really complicated parts. So that's one of the benefits. You can create often lighter and strong parts because you can kind of dictate the geometry that you want to have support structure where you need it. So if you have people that are good at working with FEA, you can see where you need strength in a part, and you can put material there rather than taking material away from where you don't need it. There are some kind of green benefits, so you're basically using the material that you need, not chucking away loads of material that you don't need, if that makes sense. So with our SLA process, all the material that we don't use is recovered. There's a bit of support material that lets us build the complicated shapes that we have to chuck away, but the rest of the material that wasn't used is still available. Whereas if you take a lump of metal and start cutting it away, milling, turning, grinding, whatever, you then have to go through a kind of a reasonably complicated reclaiming process. Whereas with our processes, we don't. We can just kind of carry on. The other option that we have is the SLS, which is a powder bed nylon. The majority of that's recovered, but one of the benefits there is we can create virtually any shape again, and they're tough. They're used in a lot of cases for actual end use parts, so not even prototype parts, for actual end use parts. We can make them any color. We can finish them back so they look like kind of on the shelf products or models for displays, or people that are taking them to investment pitches. So there's a real kind of breadth of stuff that you can do with it. It's great for kind of repeatability. If you want low volumes, medium volumes of specific parts that are complicated, you don't need to go to injection mold tooling that can cost you anywhere of kind of £10,000 upward, even for a small part. We can do that. You can increase traceability. You can stick a part number on every single part that's different without adding any cost. Whereas in manufacturing, kind of traditional subtractive manufacturing, you'd have to be doing that as a secondary operation. There's no tooling cost, which is great. So we the main kind of benefits for us are we can help people go from prototype to end use in a number of different materials pretty quickly. The speed that we've been able to get through some stuff, even this last week, we've had a customer wanting prototypes for a medical device, and they've got a kind of desktop 3D printer at their site, but our design team have worked on the design. We've been able to then produce it and get it into the customer's hands in less than 24 hours, and we've done that a couple of times on different iterations. So as people want to create, we can help them create quickly. Basically, they can get the products in their hands to see if they're doing what they want them to do.
No, fantastic, and absolutely unlimited number of advantages by the sound of it. And so you touched on, applications and some of the industries. Maybe you can elaborate on that in terms of, and maybe illustrate that with a case study to give our listeners a better idea of what you actually, do and what benefits you bring.
Yeah, no problem. So like I say, there's kind of two main areas that we work in, which is the prototyping and end use parts. And one of our customers has very specific needs on what they want. They work in a subsea environment. They do they kind of do applications for commercial diving, subsea scanning, all this sort of stuff. So they need parts that are both robust in the sense that they can be chucked on boats and then thrown in the sea and taken down by divers. So they've got to be reasonably robust, and they also are quite specific on their geometry. They're very complicated, so you wouldn't be able to tool them up in a traditional injection mold setting. The volumes aren't enormous, but we've helped those guys to produce the stuff that they need, so that it is. We've worked with them on materials, so they've got stuff that is they can kind of get sonar through the materials, but it's totally encased. Their electronics are totally encased, so that they're waterproof, they're safe, they keep on working, they can do the scanning that they need. Also, that they have these kind of chassis that we produce that they fill with other electronic devices that their divers can take down and measure stuff underwater. But we've worked with them over a good number of years, reducing the weight of their parts so that as they fill them with electronics and weigh them down, the chassis that we're creating kind of help to make it easier for the divers to take them, to kind of take the weight of that as they're swimming underwater. So we work with those guys, Blueprint up in the northeast, to help them with the kind of commercial application of that. And it's great to feel like we've got a good partner in both in R&D and in end use products there, where they can come to us and say, at the drop of a hat, I need 6 more of these parts, and I need them delivered in a couple of days, and we can turn those around for them so that they've got what they need. They don't have to store hundreds of parts that are expensive. They can just have them made as they need them.
Yeah, no, that sounds fascinating. We could probably talk all day, couldn't we, about different applications. You'll have a medical one, you'll have an automotive one. But if we just generalise now and talk about the adoption of 3D printing and current trends and maybe the effect of the pandemic, what are your opinions on that? If we start with the adoption of 3D printing, are we seeing, I think I know the answer to this, but are we seeing more and more people use the technology?
Yeah, totally. It's becoming more and more part of people's supply chains. We've noticed that over the years, we've moved from just being a prototype provider to being an end-use production provider, which is great because you're kind of part of the actual end use. It's less you're less in that space of people having a look at it, seeing if it works, and then throwing it in the bin. They're actually using the parts that we're making for what they're really meant for. So yeah, additive is definitely becoming a significant key part of the supply chain. One of the benefits of that is that basically you don't have to keep parts on the shelf as well. You can just make them as you need them. You can tweak them for different customers. You can have them in different colors for different customers. All those sorts of things are really beneficial as end-use customers are wanting products to be more and more focused around them and their company or the way they want to use them. Additive gives that great opportunity for slightly tweaking at minimal cost. So we're working with a number of different companies, slotting into their supply chain, their production processes, to help them achieve better for their end customer, whoever that may be. But it's definitely taken off, and I mean, to the point where you can every now and then you could pick up a 3D printer from Aldi for a couple of £100 to actually see what it's like. They're quite different to the ones we're running. They're the kind of spaghetti and chewing gum type things, but they let you realize in 3D, you can get it in your hand, a part that you've developed in a CAD package or downloaded off the internet or whatever. You can see what it's like, and the speed that you can do that, and the fact that you can generally run these machines lights out without people standing over them, turning handles or dials, is great. You can run them virtually all day.
We don't like to talk about the pandemic too much, but have you had any positives or negatives from the pandemic?
Yeah, we've seen some significant benefits. We've seen a lot of our kind of new customers who have previously been importing their prototyping or additive production from the Far East want to reshore it and bring it back to the UK. And we've been really pleased to help those people. It's been really interesting to kind of see other companies that are using the same process that we're using come back and join us and kind of partner with us in, again, with R&D and working on to production volumes of things. A lot of that's been kind of prototyping, but there's been some production that's come back from the Far East, so that's been good. We've had some negative effect of material supply, if anybody out there has been trying to buy a new car of late and been told that they can't buy a new car because there's no silicon chips available, we've had some problem in getting hold of silicon, not silicon semiconductor chips, but just liquid silicon that we can make vacuum casting tools out of. But again, we're kind of coming through that now, and we've bumbled our way along, which has been a bit of a challenge, but we're getting there. We've also seen more entrepreneurial customers tweak what they're doing if their current company has basically been significantly affected by the pandemic. They've been able to kind of pivot and bring out new products into new markets. We've seen people move from sectors that are not kind of health conscious, health focused, move to producing and developing new products that are trying to help reduce the effects of the pandemic, and sterilizers and things like that are some of the significant areas that we've done some work in kind of during the pandemic. And hopefully obviously it's on its way out. We don't do an awful lot in the kind of aerospace sector. We do a little bit, but not very much. And as that starts to pick up, hopefully we'll pick up more of that work. It's not affected us directly, but obviously for some companies out there, that's been significant.
Yeah, I agree. Just a final one for me, really. In your opinion, what's the future for the sector over the next 10 years and beyond? And also for your company, if we were to sit back down, and I hope we do, in another 2, 3, 5, 10 years, what are you going to be telling us that's different?
Yeah, I think that's a really interesting question at the minute. Where is additive going? There's so many new technologies coming out. Basically every few months, somebody's done a tweak to one of the existing technologies, which is absolutely what we want to see. People are bringing out new, more effective, more efficient, greener processes. I was at a conference the other day when somebody was kind of sharing their new technologies, and you kind of think it's great to see that people are saying, actually, the issues that we've got to face ultimately are the green ones. We've got to find ways to do additive manufacturing more and more greenly. One of the difficulties of subtractive manufacturing, kind of traditional manufacturing, is that can be quite difficult if you're spending a lot of energy producing steel and then throwing a big chunk of that away. Additives kind of working into that space, both in the plastic and the metal side of things. People are developing interesting ways of doing additive manufacturing with robots, so not just within a kind of specific machine, but where you can, that in the metal side of things, people running robots that are spraying metal and sintering it onto a part that may have previously been traditionally manufactured or cast. They're doing that with additive now. So it's really interesting. I think we're going to see a significant increase in the adoption of additive processes into production lines. I think that'll become more and more common, where factories are kind of absorbing that and saying, yeah, it might take us a little bit longer than it would to injection mold it, like for an individual part. But when you want the ability to tweak and change at the drop of a hat, then I think additive is basically your only option for that, and we'll see that increase.
I agree with you. Within 10 years, there'll be an Amazon of 3D printing, whether it is Amazon, and things domestically around the house that you maybe want to hinge and things. Maybe instead of stocking 1,000 different hinges, maybe there's in the cloud somewhere, there's all these hinges, and you just say the one for your door and it gets printed off and it's in your house the following day or the day after that, maybe. I don't think it sounds crazy, but I don't think we're a million years away from that, personally.
No, I think you're right. I think that's one of the exciting things for me about additive is the fact that basically, if there's a shape, you can produce it, and if hinges, anything that you need could be produced.
Yeah, no, absolutely. Well, a fascinating conversation, Rich. Thank you so much for coming on the podcast. We've enjoyed it. Please do come on again, and good luck for the future.
Yeah, thank you very much,
Stuart. Fascinating interview. Nice to learn a little bit about additive manufacturing.
No, absolutely, and great to see the company doing so well. And Rich's passion and knowledge is extraordinary, isn't it?
Yeah, absolutely. As we always say on the podcast, we don't get time to cover all the positive UK manufacturing news. There's an abundance of it at the moment. Most of it you will find on MTDMFG, so please do go to the website, mtdmfg.com. Do download the app. It's available for Android and iPhone and Apple. If you want to appear on this podcast, please do drop us an email, podcast@mtdmfg.com. But Richard, let's get back on with the good news. Coca-Cola is to invest 11 million to reduce emissions.
Yeah, it's certainly been a theme this year. So Coca-Cola Euro-Pacific Partners, which is the largest independent bottler of Coca-Cola globally, has announced an £11 million investment in the next 5 years in its manufacturing sites in the UK. And this is part of its drive to become net zero by 2040. The investment will see its 200-strong fleet of material handling equipment, including some gas-powered forklift trucks, which they use to move over 520 million unit cases of product around the site, replaced with units powered by lithium-ion batteries, producing no carbon emissions in their day-to-day operations. So, good news for Coca-Cola and good news for the environment. Yeah,
British Salt, they're expanding their site in Middlewich.
Yep, they're set to build a new distribution centre, just over 184,000 square feet, at its Middlewich site in Cheshire. The multi-million-pound facility will support its existing operations and also a new factory which will be built on adjacent land. The new manufacturing facility, which will be the first in the UK to produce pharmaceutical-grade salt, has already been approved by planners and building work is due to start later this year. Just a bit of background, British Salt was founded in Middlewich in 1969 and is now part of Tata Chemicals Europe. It provides more than 400,000 tonnes of salt every year, which is used in a range of sectors. And it's said that its products are used by every single person in the UK every single day. Quite a stat.
Wow, that's quite a statement, isn't it?
Yeah, it certainly is.
Staying in Cheshire, Tiger Trailers, they're launching they have launched, in fact, a recruitment drive. I can't help but note this got a lot of traction on social media, didn't it? And with good reason.
Yeah, I mean, it was helped by a fantastic video that was put out by MTD and Jefferson. And great video. So they're ramping up production. They're creating 50 new jobs at its £22 million factory in Winsford, Cheshire. The 168,000 square foot trailer production facility opened in 2019, already employs more than 200 people. Various jobs on offer if anyone's interested. Forklift truck drivers, operatives, fitters, electricians, coach builders, welders. There might be something there for us, Joe. You never know.
Yeah, I doubt it. I doubt they'd want me, Stuart. But just the final one today, Appledore Shipyard has secured a major contract with the RNLI. Yeah,
really pleased for Appledore. So at Harland and Wolff, the shipyard and energy infrastructure group with over 160 years of maritime and engineering pedigree, has announced that its Appledore Shipyard has signed a framework agreement with the RNLI for the haul-out repairs, maintenance, refurb and associated works for the RNLI's fleet of lifeboats. they've currently got a fleet of 431 lifeboats, would you believe, 238 lifeboat stations that will require repair and maintenance on a regular basis in order to keep them active and ready for deployment. And just a bit more about the yard. I mean, the yard in Devon, Appledore, founded in 1885. It was acquired by Infrastructure, the owners of Hull and Wolf, last August, after it's closed by its previous owner, Babcock, in 2019. So really good to see the resurgence of Appledore.
Yeah, no, absolutely. It's great. I had no idea there's so many RNLI stations out there. Quite something.
It's quite comforting to know, though, isn't it? But yeah, astonishing number. And it's obviously a charity as well. So, they do fantastic work.
Yeah, so if you get in trouble offshore at your holiday home, on your various holiday homes around the UK, it's you know who to call. But thanks for your time. That brings the end to this week's podcast. A big thank you to you, Stuart Whitehead, Rich Proctor, Managing Director of AME3D, a fantastic special guest. As always, our biggest thank you goes out to you at home who have taken the time to listen to the podcast. We'll see you next week.
To the Great British Manufacturing Podcast. Don't forget to subscribe and leave a rating and a review. You can find us on Twitter using @MTDMFG and @Jefferson_MFG.